The reproductive system in human beings. Out of all the systems that we've played with, of all of the systems that you've learned about, when it comes to long-term success, this is the most important system. This is how we procreate. This is how we leave babies. This is how we evolve. We make offspring that are different than us, but not too far from us. But no child is exactly like mom or dad. You might have dad's nose, you might have mom's ears, but you're not mom, you're not dad. You're your own unique individual composition of your genes, unless you have an identical twin, but that's another issue. In order to get into this system, I want to do a little refresher. I want to take you back to the world of meiosis. More than likely, hopefully somewhere in the dusty recesses of your mind, you remember mitosis. Mitosis is essentially cloning. We take one cell, the mother cell, and we turn it into two offspring cell, or what we consider the daughter cell. What we're doing is we're taking a diploid cell in mitosis, and if you remember diploid or diploidy is where each one of the chromosomes exists in pairs, 2 number 1s, 2 number 2s, 2 number 3s, and for us humans, that's 46. So I'm going to be using that 46 number often. We can find aberrations in that, but typically it's 46. If I take one of my diploid cells and I fuse it with someone else's diploid cell, I end up with now an offspring that has cells that are 92 chromosomes in size or in count, and that's not going to work well. So what I need to do, what we all need to do, what our parents had to do to make us, is we had to reduce the number to haploid, what's also called a reduction division, along with the term meiosis. Haploid, we only have one of each. So my mom, she contributed 23 chromosomes to me. My dad contributed 23 chromosomes to me, and here I am, a diploid organism with 46. This has worked very, very well. The human population is well over 7 billion, so yeah, it's worked fantastically. So what we need to do is we need to look at how males and how females pull us off. Our systems, my reproductive system as a male and a female's reproductive system are vastly different. The goal is the same, but how they work is very, very different. Males, we have a really easy time of it. We're not that complex, we're really simple. These haploid cells that we make are cheap. They're a dime a dozen. And we essentially contribute nothing to sexual reproduction except those haploid cells, which we call sperm. When we get to female component of this system, yeah, now we're digging in. There's a lot. Females are much more invested in sexual reproduction. So this isn't a 50-50, mom and dad are both vested in the same way. No, mom, females have a lot more to do. So I want to try and break this up into two sections. I want to talk about males first. Like I said, we'll get the simple thing out of the way. And then I want to deal with the female system. So we're going to look at this anatomically, we're going to look at it hormonally, we're going to look at it in a cellular aspect. And I think where I want to start males, it's the same place I'm going to start females, is looking at that process of meiosis. But we're going to be specific as to the cell that we're going to make. Males, it's called spermatogenesis, which translates literally to the origin of the sperm. Now here's our meiotic division. So here's meiosis 1, meiosis II. There's that same diploid, haploid, haploid all the way across. And then the difference with this last step is we just see a change in the morphology of what ends up being the spermatozoa. So as far as terms here, don't worry about spermatogonia and cell growth. But we'll start out, our original cell will be our primary spermatocyte. After we go through meiosis I, it becomes our secondary spermatocyte. Once we go through meiosis II, we call them spermatids. And then when that morphological change happens, we call them spermatozoa. So here's a trick that I use to remember which one is which as we go through this process. They kind of sound similar and you can confuse them. Here's what I key on. If this will work for you, great. Spermatocyte, spermatid, spermatozoa. And if I look at those C's, the T's, and the Z's, they're in alphabetical order. So it's something that for me, it works. So if not for you, then I'll let you try and figure out another way, or maybe you just don't find it as confusing as I do. So this is very, very close to just standard meiosis. We have all four at the end, and the reason I'm saying that is when we get to females, it's not quite so simple. Now I've put a number up there, 400 million per day. That's not really an important number, and that's how many spermatozoa that males produce in a day. That translates to 300,000 of these cells per minute. There's a lot of meiotic division that takes place in males. In females, once we get to that system, you're gonna see it doesn't happen nearly as close. And these are very, very, like I said, cheap and simple to make. If we take that spermatozoa and we blow that up, I want to look at the anatomy of it. Also, one other thing before I go to this next slide. To show you a difference between male and female reproductive systems, males have what's called a urogenital system. So uro, starting with a U, not an E. Urogenital means that males, we have one system that is involved with the urination as well as reproduction. When we get to female reproductive system, no, it's a totally dedicated reproductive system. You don't find a fusion between the urethra and the urinary system and the reproductive system in females. You'll see that as we go. So let's take one of these spermatozoa and blow it up. Well, let's take a look at this one first. This is what they look like. Anatomically, we've got a head, a little mid-piece, or a body, and a tail. This allows for these to locomote, to move. And actually, the reason males are called males is it has nothing to do with, oh, this male has a penis or anything like that. It's because the male makes what we're going to call a gamete, those haploid cells, that locomotes. It moves. If you produce a haploid cell, a gamete, that is big and it doesn't move, we call it an egg and we call you a female. So that's what it comes down to. It's not a penis, vagina, breast, no breast thing. It's all about the gamete. So if we blow this up, let's go to this. Here's the head. Here's that mid piece. And here's that big long tail. Now let's look at some of the anatomy with this. The head, I'll do it over here, is haploid. That's where the 23 chromosomes are contained. And on top of the head, there's this little thing that looks like a ski cap called an acrosome. Now, if I drag you all the way back to what you know about organelles, the acrosome is going to have digestive enzymes in it. It's going to allow this cell, this gamete, to be able to digest its way into the egg. That's a modified lysosome. And so you probably learned ages ago, yeah, lysosome, digestive enzyme. Well, what these cells will do is they'll modify it, they'll stick it out on the top of the head. Down through the mid-piece, or the body. The most important thing here is what's referred to as mitochondria, the powerhouse of the cell. This is where energy is generated in the form of ATP that is going to allow the tail to move. Now, one thing I want to point out while we've got this big variation on anatomy up here is this. When fertilization takes place, this on the top is the only portion that is going to end up entering and combining with the DNA from the egg. That's it. So everything down here, Dad doesn't contribute any of this. So my dad contributed to me 23 chromosomes. No organelles, no cytoplasm to speak of. All of that came from Mom. Once again, it shows you this lopsided, who has the bigger responsibility when it comes to sexual reproduction, and it falls on the female side. So how do we do all this? How do we make these? Well, males are going to make them using the testes. There's a whole lot of anatomy up here. There are a couple of really important components that I want to kind of key in on. But I'll do that as I watch the time wane on the next video.